right, intermediate algebra students, we're working on Module 2, Homework 5, where it's about scientific notation, exponential powers, and all kinds of rules with regards to it. So when we're dealing with exponential powers, this first rule is very important, and it's not really, I have to write too much because it's already been given to you right here, but anytime you have the same bases that you're working with, you simply add the exponential powers to the same bases. Whenever you're multiplying, you have to be multiplying. That's what that little dot there is that you're multiplying. So for WP, all right, times WR, all you're doing is simply putting WP plus R, and that's it. There's nothing else you can do for that. I mean, you're simply adding the exponential powers. So that's why the answer is what it is. So then when you're dealing with Z17 times Z10, then all you're doing is adding the 10 and the 17 and get 27. And it's really, really simple, huh? I mean, so we have that. And then it says simplify the following by writing it as a number to an exponent. So when you're dealing with numbers, you do the same thing. It's the same thing as if you have variables. All you're doing is adding the exponential powers together. So it's going to be 3 to the fifth is 5 plus that 4, which is 9. So we're going to do 3 to the 9th power, and that's what we get for that. All right, that's all we have to do for that. Really, really simple. Now, I want you to take note over here with this right here. When you're doing this is significantly different. You do not add the exponential powers together just because you're adding here. This is a completely different thing. All right. So it says we can only use the product rule when multiplying expressions together. Remember that exponents are simplified before addition in order to do the order of operations. So we go ahead and look at this one. It would be 4 plus, and then we have 8, and then that would be 12. All right. That's completely different on how we do that. All right. We do not proceed to do that for this kind of situation. So please be careful. Now, the quotient rule of exponential powers is where we have multiplication right here. Multiplication results where we add. Well, with division, you subtract, and that's what you do with the exponential powers. Now, I'm going to take it a step further in just a minute, but so all you got to do is take this when you're looking at this and just bring this up to the top, and when you do, it becomes this. Actually, all right, it literally, this exponential power becomes its opposite. I wanted to show you that. All right, this is literally what happened is that you bring it up to the top, this whole entire thing, you bring it up to the top, and then you switch the sign of this exponent, and that's why it becomes like that, and you can proceed to do this. So our answer is K minus H. For that, it's B raised to K minus H, obviously. So likewise, you do the same thing for y to the 16th over y to the 5th. You bring this up to the top, and I'm purposely doing it this strategy because I'll talk about later what we do, all right, when we're dealing with simplifying radicals. So now this becomes negative 5 because it's bringing it up. So now it's 16 minus 5, and that we can do that in our head, and we get 11. All right. Again, if you're trying to keep up with me, as some of you are, you don't have to write all this work down. I mean, you can just take 3 and then 6 minus 2 in your head, right? 6 minus 2 is 4. You don't have to write all this stuff down. I'm doing this for the sake of just your thought process should go, but it's not something you have to basically write. You can see I did it just mentally right here. All right, and likewise with the last one, it's 2 to the 7th power minus 2 to the 3rd power. Now I do wish to share that with you on the calculator. I mean, I do care to show you some things on the calculator. You know, I know how to do it physically with you, but I do 2 to the 7th power, and then I take and do minus 2 to the 3rd power. and you can get your answer pretty quickly that way too. All right. Um, oh, geez. I thought I was only showing it to you. I wasn't. All right. So you can do it like this, okay, in the calculator. So you can do it on the calculator for some of this, okay, but that's not what we're trying to aim for with the process of knowing your quotient rule, the product rule with exponential powers. Now you have the power rule, power, power. That's when you multiply. So if you go ahead and have, all right, y with a raised to the c power, and you're raising it to the c power, and you simply multiply these two parts out, and you get y to the cd power, as its multiplication. And that's what that means. Whenever it's power, power, I call it. Okay? So power and power. So you multiply. So then when you get w, and then you have the 3 and the 6, you multiply 3 times 6, and then you put down the answer, and then that's your answer is, 18. Okay? Likewise, you have 3 raised to the 15th power. Really not much I can explain there. I mean, just multiply the two numbers together. Now, likewise, when you're doing this, I always like to think about if you have singular base and you have multiple, exponential powers, you multiply them with singular base. When multiple base like this, when you have 2, 4 times 2 to the second, that is coming back up here and doing the power rule. So what we do is get 2, and then we have adding these two together, we're going to get 6. Rather than multiplying together, do not multiply it together if it's multiple base. All right? So again, you can punch it in your calculator, and see what's nice is getting to know your calculator. You do 2 to the 4th power, and then times 2 to the 2nd power. I had to make sure I got away from the exponential power. All right, and then we get that. Okay, and then the thing is automatically giving our answer. Okay, because what it's doing is it's taking 2 to the 6th power. All right. Now, if it doesn't want us to go ahead and put it as an answer, it's going to be where we just have 2 to the 6th power. All right. But this one, I believe they want us to do 64. Now you have the zero exponential rule, which is anything raised to the 0 power is equal to 1. All right. So those are good things to remember. Okay. Anything over itself is equal to 1. So kind of really important to see that anything raised to the 0 power is equal to 1. So the answer for this one is 1. The answer for this one's 1. The answer for this one's 1. Now, take note, 0 to the 3rd power, what does that equal? That's 0, right? Because 0 times 0 times 0. So don't get confused when the base of the power is 0. All right? So that's really easy to understand. Now, the expansion rule. See, there's so many different rules. That's why students don't like exponents. Anything that deals with exponents, they don't like all these rules. But they're not that complicated individually. It's just a matter of you recalling them. And you can write them down and then just use them as you go. It's called practice, right? So you practice using the rule. So I like how this is written out. The way they describe it up here is that power is then multiplying all the powers of each individual item. That's the power rule. It's this rule, but not this rule. That's the 0 rule. It's this one. It's the power rule, but it's using it on multiple terms. All right, so we go ahead, and if there's a raised to the 3rd power or something, or a raised to some kind of power m, then it would be m times n and stuff like that. So it's a matter of doing the power rule to multiple things. So we have CW raised to the h power. We're going to get c to the h power times w to the h power. So you distribute this out basically to both things. You're not multiplying them, you're multiplying the power rule, or the powers. So there's our answer. So when we're doing this, 3 over b raised to the 5th power, then that's 3 raised to the 5th power, and then b raised to the 5th power. And 3 to the 5th power is 243 over b to the 5th. So we have that answer. All right. So I gave you both answers. All right. Now, when we're looking at this, now I like this question, this next one right here, because it's you're looking at the power here. This power applies to the 7, and then it applies to the 2. So it's 7 to the 3rd power, and then it's 2 times 3 is 6, so it's x to the 6th power. And then I take the 3 and raise the 5 to the 3rd power. All right, so now we got that. We can go ahead and carry it out. And then it'd be 343 x to the 6 over 125. And that's what it's going to show you here. All right. So I like when, to write this means to go ahead and then simplify it further, right? So I don't think you have to propose it on. I think it's going to accept this as your final answer, but you can check it out when you're doing your homework. Now, when doing this one right here, okay, a lot of students mistakenly think that this means the same thing as what we did here. Well, this is a binomial. You don't do that with this situation. You don't apply this to this and to that and then do it the same here. It's not like a distributive property. And that's where students are confused. It's not that way. All right. When you have a binomial, it's literally this times itself. It drives me nuts seeing students just, this is not the answer. It's not going to be 49t squared plus 16. This is wrong. And that drives me nuts to see students doing that. Okay? So that's completely wrong. It's because if you're going to look at this, multiply this together, you're going to get the 49t squared as you would have regularly, but then you got to multiply this times this, and then you got to multiply this times this, and then you got to multiply this times this. So then you would get this added together to give you the 56, yeah, 56t. And so that's what we get right there. And so look at what the answer comes out. And students are going to come up with some goofy answer where they're going to go ahead and do this business, and it's completely wrong. All right? So I went ahead and showed you that this is exactly what's written there. Same thing means that. And then, of course, doing the expansion process or the evaluation of it. That's the answer we come up with. So now, no more giving of rules, per se. They're not giving any more rules. You just got to now go ahead and apply the rules. Okay, so here's to simplify this. So you have the same basis. We're going to go ahead and add the exponential powers together and get 28, and we're done with it. And that's that. That's the answer. Oops. Sorry. So x raised to the 28th power. All right, and then this is the power rule, so it's going to be 9 times 11. All right. The attendance code is something you do when I give you the first couple minutes. So you're going to have to stay after class and get the attendance taken care of. Then. All right. Now we're going to go ahead and multiply. We're going to get W, and then 9 times 11 is 91, and that's it for that. See, now when you know the rules, and you're doing these problems, they move very quick. All right, very quick. So I'm going to take -4, raise -4 to the 4th power, and then multiply 4 times 4 is z to the 16th. Now 4 to the 4th power is basically taking 16 times 16 or 256. Since this is negative, it's negative times negative times negative. Anytime you have a negative, multiply it against a negative, that equals positive, right? And then you multiply it against another negative, that equals negative. And then you multiply that against another negative, you get back to positive. So anytime that this is even and you're dealing with negative, that's going to be positive. Anytime it's odd, but if it was like say, let's say negative 4 raised to the 3rd power, all right, then you would have a negative times a negative times a negative, and that's when it would be equal to negative. So anytime you're dealing with it, you evaluate signs first. If this is even, and this would be positive. If this is odd, this would be negative. And then you just take the valuation of 4 to the 4th power, and then you get the 256. 256 z to the 16th. All right. So I'm giving some strategies that are going to keep it simple. All right, but you got to apply all these different rules. That's why students don't like math, because there's so many rules that can be used and applied, and it's about recalling those rules. Okay. All right, now we look at number 9 here, question number 9. We see that we have 5w to the 6, 3w to the 8, and then we have 7w to the 3rd. Now, what we do, since we're multiplying all these together, we can multiply 5 times 3 times 7. We can also do, 3 times 7 is 21. 21 times 5 is 105. All right. And then we go ahead and do 6 plus 8 plus 3. 8 plus 3 is 11. 11 plus 6 is 17. So we get w to the 17th power. So I went ahead and did that all immensely, but you can see that what I was doing, I hope at least I explained what I was doing. If you can't do it mentally, you can use your calculator, but I think using mental mathematics helps your brain speed up. All right, so please try to do it mentally as much as you can if you can. You don't want to sweat small stuff out. Question number 10. I love this question because it really just helps the student understand the difference between what this means and what this means. It's about understanding the order of operations. What this means is that, remember in PEMDAS, please excuse my dear Aunt Sally. Excuse my dear Aunt Sally. PEMDAS. Well, it says that you're supposed to do exponential power before multiplication. So what this really means, another way of writing this is -1 times 7 raised to the 2nd power. That's what that literally means. But we don't write the -1 times. That's just not something you do in practice. This is the way you describe it. So what you have to do is do 7 to the 2nd power, or excuse me, 2nd power is 49. And then you go ahead and multiply it, because we're doing exponential power first, and then multiplication. -1 times it gives you -49. But then if we look at this, this is -7 raised to the 2nd power. Now all we're doing is the exponential power, or the exponent first. So it's -7 times -7 is what you're doing then in that case. And -7 times -7 is +49. So there's a difference between when you're looking at with parentheses and without parentheses. And if I have to say so myself, that was probably one of my better explanations. All right, I have to pat myself on the back sometimes. All right, now x to the 3rd, x to the 4th, you add the exponential powers together. I'm not even going to write it down. That's going to be x to the 7th. And then the power rule is 3 to the 4th, or I should say x to the 3 to the 4th, is going to be x to the 12th, because 3 times 4. All right. See, I like these questions again because they're showing you the difference between what this means and this means. All right? It was what they warned you in that yellow earlier. Now, whenever dealing with this situation here, treat this as they're separated. Treat all parts as separated. So when we're looking at this, right, we think about this as like little dashed lines between them. Now, what does 2 over 8 give us? That gives us 1/4, right? Because 4 goes in, 2 goes into both of these, and 2 goes into 2 one time, and 2 goes into 8 4 times. And now I bring this up, separate away from the 1/4 that we have right here right now. I bring this up because I want a positive exponential power. So I'm going to get a to the 5th minus 3, and that's going to be then a resulting value of 1 times anything itself. So a to the 2nd divided by 4. And that's our answer that we're coming up with. And the way I'm describing it to you, and the way I'm explaining that, is going to be leading us into like question number 13 and so on and so forth, where you have these parts. All right? Now, here we have 2a raised to the 5th, and then we have 8a to the 3rd. Now, 2 to the 5th power, all right, is 32. And then a to the 5th. And then I'm going to have a to the 3rd, still down here, and then 8. Okay? Now I go ahead and divide 32 by 8, and we get 4. And then I'm going to raise this up and subtract 3 from 5 and get 2. So I'm going to get a to the 2nd. And there's our answer for that. Now, of course, some of you are thinking to yourself, well, I didn't know what 2 to the 5th power was. I know what it is, but you didn't. So just take it in your calculator. It's not that big of a deal. Just take a calculator. I mean, I'm not saying just, I know you're probably overwhelmed because I'm going so fast because I know values, but you're going to have to, because you don't know them, you're going to have to take 2 to the 5th power and then write it down, 32. All right? Don't say I'm just generating numbers out of the top of my head or anything. I am, but I mean, I know what the answer is, but you can get it from the calculator as well. All right. And then if you don't know what 32 divided by 8 is, you can go ahead and just do that. 32 divided by 8 gives you 4. And that's how I came up with 4 as my answer. Okay. And then some students get overwhelmed by teachers because it goes so fast. But the thing is that we're teaching a whole bunch of different types of style problems. So teaching not so much as based off of numbers, but the process. The process is what I'm after. The numbers always change, so I don't care about the numbers. I care about the process. Do you understand that it's 2 to the 5th power is where I get 32? That's what you need to understand, right? So now moving on to, that was question 12. Now on 13. Now it's getting a little busier, right? You can get that feel, a sense that it's like, wow, there's a lot more stuff here. So you get into these parts, and I want to show you that it's not a big deal. We just simply are applying our properties to these concepts and getting it isolated or combined. I like to combine my things. I think of this as a big puzzle. So the big puzzle is that, this is 1, and then, oh, wait a second, what's going on with this? So here, I'm going to go ahead and teach you. Now we're distributing this to here, so 2 to the negative 2, and then 2 times 3 is 6, and that's negative 3 times negative 3, right? Is 6, and then same thing goes for this. This is also 6, and notice how it's positive now, right? It's negative times a negative, and then I still have this going on here. And now because this is 1, I don't need to include the c at all. So I'm now going to go ahead and I want positive exponential power. So I'm going to bring this up as well as this up. And remember that whole dashed line business. I'm treating these as separate parts. I mean, I don't feel like drawing it in parts. I'm not going to, but I'm literally doing this. I'm keeping only my parts together. So now, whenever I have a negative 2 like that on a on a value of this. I don't want to evaluate it with the negative 2. Some students do that. I want to go ahead and just keep, or make it positive is what I want to do. So I'm going to bring it down and then make it positive. And I'm going to show you my next step, what that looks like. So bringing up a to the a to the 6 is going to give me a to the 5th, because I'm subtracting 1 from 6, subtract 2 from 6, and I get 4. And then I'm bringing this down, and what does that look like? It looks like this. See, now I have this positive. Anytime I bring it down or up, above or below the exponent or this line, okay, then I'm going to go ahead and switch the inequality, or not switch the inequality, but the exponential power. Now, if that's the case, then I get 2 to the 2nd power is 4. 4 times 2 is 8. So my answer officially then is a to the 5th, b to the 4th, all over 8. And that's my answer. I'm looking for that. All right, and it looks like we got the right answer. Number 14. Now it says simplify the expression completely using only one exponent in all of your answers. Okay, so now we have this. So we have to go ahead and distribute this out to this, distribute out to this, and this, right? It's like the power rule, what we talked about earlier. All right, now 4 to the 2nd power is 16. Y to the 2nd times, or raised to the 2nd power is y to the 4th. And then 3 to the 2nd power is 9. I can't simplify that any further. There's my answer. All right. Now, I just did the wrong one there. Here we go. And there we have it. All right. Now, 15. I gave away the answer. Now, I'm taking 3, raising it to the 3rd power. So I don't know if you need me to write this down, but I will. But I shouldn't have to. But I'm taking this, and I'm raising it to the 2nd power. So 3 to the 2nd power is 9. 3 times 3. Then 2 times 5 is 10. And then 2 times 4 is 8. All right, I'm done with that. These move very quickly when you know what you're doing. All right, now let's go ahead and it looks very intimidating when students are looking at this. They're like, oh my God, there's so much going on here. But if you got to take a deep breath and just calm down and just handle it one moment at a time. What I mean by that is like this is one moment, and then we have this another moment. So we're going to go ahead and figure this out together. All right. And the one critical thing is you do not want to make any real rational decisions. You want to keep everything in check. So, first of all, let's clear off these exponential powers. So, that's 5 times 5 is h to the 25th. And then it's 6 times 2. 6 times 2. 6 times 5 is 30. That's expensive. Then I have negative h. Now, negative h is really negative 1 times negative 1 times negative 1. But it's negative 1 times. So I'm raising it to the 5th power. And after our discussion regarding to this right here, I wanted to bring your attention again to it, that when you're doing negative powers or negative signs involved in it, when you're doing it, anytime it's odd, you're going to have it negative. Anytime it's even, it's going to be positive. So when we come back to this problem now, all right, we know that this is going to be a negative 1 times negative 1 times negative 1, which is negative 1 after you do it 5 times. So now it's going to be 5 times 4 is 20. And then 5 times 3 is 15. Now, this also has a negative sign in it, all right? But it's being raised to the 4th power, which is even. Oh, excuse me. I already wrote it down here. When it's even, I'm going to go ahead and take the negative sign and erase it. That's what I do with that negative sign, all right? And then I have h raised to the 4th power, which I'm going to take and put h to the 4th power. T, you see what I did was I brought this over to here, put it with the h. And then I'm going to get t raised to the 16th power, that's 4 times 4. And then h to the 2nd time, raised to the 4th is h to the 8th power. All right, I have that. Now, I have multiple h's in the bottom that I got to clean up. I got stuff all over the place going on. What I'm going to do is I'm going to go ahead and clean up the top, clean up the bottom, because I got a couple things here I can simplify. So I'm going to go ahead and do that. Now, negative sign, I'm going to put a negative sign in the front, and then I'm going to put h to the 20th added to 25 gives me h to the 45th. I got t to the 30th, and then t to the 15th. I'm going to go ahead and add those together and get t to the 45th. All right, and then I'm going to go ahead and add these two together, get h to the 12th, and then t to the 16th. Now that I have that done, I'm going to go ahead and subtract, because it's a subtraction property, right? Or subtraction of exponential powers when dealing with division. So subtracting this from this, I'm going to get negative, by the way, because it's negative. Then I'm going to get h. Subtracting this from this is going to give me 33. Subtracting this from this is going to give you t, and then that's going to be what? 9, 29. All right, so there's my answer that I'm coming up with. Let me see if I got it. Oops, it looks like I got the right answer. That's good. All right. Like I said, I took my time. Of course, adding some things in my head. If you can't do it in your head, you're gonna have to go ahead and use your calculator. Not a big deal. So 17. Now you got 5x to the third. You got y, 3y to the second. And all that again. 3 to the third, y to the fifth, 5 to the second, x to the sixth. All right. Now let's take a look at this. So I got 5 raised to the 5th power. Okay. 5 raised to the 5th power, I can't do that off the top of my head. Darn it, I can't do it off the top of my head. 5 raised to the 5th power equals, yep, that's a little high. Alright, so that's a little high. I can't do that off the top of my head. Sorry, guys. I think you have some forgiveness on that. Alright, so 3,125. Alright, and then it's x, and then it's 15 because 3 to the 5th, no, 3 times 5. And then I'm going to go ahead and do 3 to the 5th power. That one's going to be the 243. Okay, and then that's y to the 10. Again, if you don't know that, all you got to do is, again, take your calculator, do 3 to the 5th, and you get the 243 right away. Okay? No big deal, just use your calculator. Now I'm taking this and I'm multiplying against, and then this 3 to the 3rd is 3 times 3 is 9, 9 times 3 is 27. And then y to the 5th, there's nothing else I can do with that. And then 5 to the 2nd we're going to get, now, one thing that you could have done, I want to show you something. I do want to show you something. Watch this. Okay, let me back this up. And rather than evaluating it at first, like I am, because I'm going to show you something. I'm going to do 5 to the 5th, just leaving it as its raw form. So 3 to the 5th. And I'm going to leave this as 3 to the 3rd. And I'll show you what we could do with this instead of doing what I did. And then we're going to leave that x to the -6. Now, what we could do is we can go ahead, when we combine this, okay, we can go ahead and take this and bring this up to the top. And when we bring it up to the top, it's going to subtract. So that's going to give us 5 to the 3rd. And then we're going to go ahead and bring this up to the top, make it become x to the 21st, because 6 plus 15. Because remember, when we jump it up, it's going to become its opposite. So if it's -6, it becomes +6 when it comes up to the top. So that's going to become then 15 plus 6. And then we're going to go ahead and bring this guy down because 5 is larger than 3. So we're going to bring it down. And that's going to give us 3 to the 2nd power. All right. And then, that's subtraction. And then we're going to bring this down because we want to make the exponential power positive. So it's going to be 10 minus 5, which is going to give us 5. Now that is like part of this like moving of pieces that is really critical for the evaluation of this. It makes it simple, and then you could do the 5 to the 3rd power is 125, x to the 21st, and then 3 to the 2nd power is 9. And there's the answer we're coming up with for that. Now, I know some of you are cringing like crazy, thinking, oh my goodness, I'm never going to get this. Yes, you will. You just got to practice. You got to work with the manipulations of the structures and just keep calm and just apply your rules. All right, apply your rules. Number 18. All right, now 4 times t to the 4th, t to the 2nd, times y. And then you have the -3. Now, there's a couple things you could do with this. I want to show you another strategy. Whenever you reciprocate a fraction, you can clear a negative, by the way, by doing that. But before I do that, I'm going to go ahead and bring this up here and make it become t4 to the -2 is 2. Okay, so when I do that, I'm going to rewrite it like this: 4t to the 2nd, y to the 5th, and I'm going to now make that a positive exponential power. See this difference here? All right, by reciprocating this fraction, it clears negative signs, by the way. I think that's critical strategy because there's no negative exponential powers here, and if there was negative exponential powers, I would have probably kept it as a negative because I would have went ahead and distributed negative and negative times a negative is positive. So I didn't see that, so I went ahead and did my strategy here, and then so now it's y to the 5th raised to the 3rd is y to the 15 all over, and then it's 3 or 4 to the 3rd power, which is going to be 64. 64. And then it's 2 times 3 is 6, so t to the 6th power. And then I'm done. That's my answer. And that's the answer to the group. Right? So I gave you another cool strategy. Whenever there's a negative, you flip it. Take the reciprocal. I know, and that's why you love me. All these great strategies. I'm not weird or what? Maybe. you need to know you can find out. That's the joke. Anyway, 4 to the 4th power. Okay, 256 again. If you're not comfortable with that, we go do 4 raised to the 4th power, and then you get the 256. This can even punch in your calculator if you can't do it next time. So 256, and then y to the 48th, and then times y to the 2. And then we go ahead and add these two together, and we get 256 y to the 46. Some of them are easier than others. This one was up there as far as easy. All right. I love a good thing coming together. See, now, here's the one that I was talking about earlier. You know how I said, if it's negative and these are all positive, then you want to go ahead and reciprocate. This is a situation where you don't want to reciprocate because of all these negative exponential powers. So, when I'm doing with this one, I'm not going to reciprocate this time. I'm just going to go ahead and bring it into it. Now, I'm gonna take a different. Now that I'm sitting here writing it down, I'm gonna take a different strategy. I mean, see, I'm trying to fill up your toolbox with a bunch of different types of strategies. We can clean this up before actually really dealing with that negative 2. So what I can do is I can bring this up or bring this down. But because this is negative, I want to leave it as negative, to be honest with you. So I'm going to bring this down, actually. All right, and when I bring it down, okay, it's going to be a to the negative 5th, because I add the exponential powers together, this is going to become negative. So it's negative 2 minus 3 is negative 5. This, I want to make this negative, so I'm going to bring this up. It's going to become the opposite, so it's going to become 4 plus 2, and that is b now raised to the negative 2. And then I have a negative 2 sitting here. So I'm now going to distribute the negative 2 to it, negative times the negative positive, remember. So that I'm going to get b to the 4th, and then I'm going to get a to the 10th, and I'm done. There's my answer. I really find this is just amazing when you're given all these strategies. That's why I'm giving you so many different ways of approach to this, so you can think about it in terms of this. It's actually really fun. I love exponential powers. It's so easy, but you got to know all the strategies and know them all good. And that's why I'm giving you everything I have to make sure you understand the different ways of approach. And maybe it doesn't work out for you, like as far as understanding it right away. So you practice it, and then you try different things. Okay, now this is negative times the negative is positive, so I'm going to do a to the 9th power. And then when we do this, it's going to give you b to the negative 9. We can't leave negative exponential powers. So we're going to have to go ahead and think of it this is over 1 and just drop this down to the bottom so you can get a fraction of then a raised to the 9th power over b to the 9th power. And there's our answer. So 22. Now we go ahead and simplify this expression. It's the same one as the one before it. So it's going to be, I'm going to write this one down pretty quick. It's going to be a to the positive 20th, b to the negative 12th, and then I can't leave it negative, so I'm bringing it down. So my final answer will be a to the 20th over b to the 12th. All right, so this one was just like this one. I don't know why we got so many of the same kind of questions, but it is what it is. Now, I have this. Let's go ahead and write it down. All right. Now, negative times a positive is negative, so I'm going to get negative 21. And then I'm going to get negative 27. Now, that's negative. Now, which one's greater? Obviously, well, 27 absolute value is greater than absolute value of 21. If I bring this up, it becomes its opposite. So it's going to become then x negative 21 plus 27. And then so since they're opposite signs, I subtract. So subtracting 21 from 27, I get 6. So that's going to be positive. There's my answer. Now we move on to scientific notation. Now, all of the strategies that we've been using for this is applicable to scientific notation, and why they go ahead and introduce it in the same concept as this. So the last 6 questions will be pertaining to that. Or 7 questions, whatever. So now, scientific notation is a number that's expressed as n times 10 raised to some power value. Now, that number has to be between 1 and equal 1, okay, 1 and 10, where it can't be equal to 10, because it can't be more than a single digit value. That's what you got to think, okay? So in this case, when we're looking at the value of 883,600, we're going to move the decimal point over 1, 2, 3, 4, 5 units, all right, in order to get the value between this. Okay. Do I have a handout? All right, it looks like we're all good. All right, and then when I move this over 5 units, 1, 2, 3, 4, 5, I have to go ahead and put a positive 5 for that. Okay. So that's the answer we're looking for that particular question. So there's the answer we're looking for. Now recall that this number has to be between 1 and 10. So when we multiply, like in this case right here, number 25, let's take a look at number 25. When we do number 25, we're taking the values of the numbers and multiplying together and adding the exponential powers for the bases of the 10. So let's rewrite this in terms of the way we do way we operate on this. What we do is we multiply these two numbers together, put a multiplication symbol, and then 10 needs to be finalized, but we need to use 3 times 10 to the negative 6. And then we're going to leave it as negative values, by the way, in this particular thing. But now, we've got to take our calculators and do 3.7, right, that's the value here, and we're going to multiply that against 1.4. Now, once we do that, we're going to get 5.18. Now, 5.18 is a number between 1 and 10, so that's okay. And then when we go ahead and do this, then this is 3 plus negative 5 is going to give us negative 2. So we're going to get this, all right? And this is our answer that we're going to leave it in for these scientific notation. And there's our answer. Now, had this been 51.8, then that would be a different story. And we'd have to do something a little different with that. Now, for our next question here, I'm rewriting it where it's the numbers are together and the variables, the exponential powers with 10 base is the same, or are together. Now, we take 6.24 and you divide that by 9.6, and you're going to get 0.65. All right, and then we have 10, and then we bring this up, and it becomes negative 6 because we add 3 to negative 9 and get negative 6. Now the issue we have here is that the value that we have is not between 1 and 10. So we have to move the decimal point over to the to the right, all right? When we move it to the right, we have to subtract, all right? We have to subtract that many units from the exponential power. So whenever we're moving the decimal point to the right, it's literally, when you have this value, right? Let's say you have this, and you need to write this in exponential form or scientific notation. What did we do? We moved the decimal point over 2 times to the right, and then we subtracted from the exponential power that many units. Well, the same thing goes for this. If we move it 1 time to the right, then we're going to subtract 1 from this -6, and we're going to get -7. And there's our finalized answer. What we come up with. So the answer to express in scientific notation is here, all right? And then answer the expression in decimal notation. So what we need to do is now move the decimal point over 7 times, or put 7 zeros with the decimal point in between the first and second. So I'm doing that right now. 1, 2, 3, 4, 5, 6, 7, and then 65. Here's our answer for that one. All right. So there we have that. Okay. 27. So remember, when we move it to the right, we're subtracting. When we move it to the left, it's adding or subtracting. When we move it to the right, yeah. When we move it to the left, it's adding. So let's go ahead and do another one. So we're going to go ahead and multiply 2.1. 2.1 times 1.7. Oh, I just did that. So it's going to be 3.57 times 10, and we'll add the exponential powers together. We're going to get -66. This one seems a little easy. Oh, just because I guess I'm done explaining it to you. That's what it is. All right. This one, we're going to take 1.32 divided by 1.1, get 1.2 times, and then we take the 6 and subtract it from the 4 and get -2. So this one's done, because we're in proper scientific notation. And then it says rewrite the number as a whole number or decimal. So what we're doing is moving the decimal point over. So it's going to be moved over 7 times to the right. So we're going to go ahead and get first part answer. These are pretty easy. All right, so we're moving it. All right, let's see if we get. Now, write the number as a whole number decimal. We're moving it to the left that many units, so it's going to be 6 zeros. 1, 2, 3, 4, 5, 6, and then 2, 13. So you always have these number 6s or number of values is what's in the exponential power, but you have to have a decimal between the first and the second one. And then the last one is 89 million, so it's going to be 8.95, and then it's times 10 to the 7th power. Because we're moving the decimal point over 3, 6, and 7 times. So there's our answer for that. All right. So that concludes all 30 questions from the homework of Module 2, Homework 5. That was quite a bit of work, but we got through it.